I enjoyed this question. I really enjoyed this question. I hope you did too. It's a really good practice, a nice opening challenge for your modeling skills. What do we have? What do we have? Vertically upwards, the ball is being thrown up. Immediately you start thinking acceleration due to gravity minus 9.8 is what I'm going to be using. Because if it's going upwards, acceleration is working against it. It's going in the opposite direction, so we get the negative, don't we? We have this point P at a height 8, so the ball is not being thrown from the ground. It's already on a height. Could be you holding it up in your hand. That's higher than the ground, isn't it? Or you can be somebody standing somewhere. We don't need to know all that information, but we know it's not from the ground. It starts from a position where S is H. And then the ball it gets down to the ground, so it gets below where it originally started at 0.75 seconds. It's below P at 0.75 seconds. And when it hits when it's just about to hit the ground, it's 6.45 meters per second squared. Okay? That's your initial model. What do you think about that? Make sense? We can model it like this. We have that height H, that's where P is. This is the starting point where the ball is being thrown. Okay? And at that point, it's being thrown up with U meters per second squared, and then when it's coming down, remember it's going to go up and it's going to come down, and when it's just about to hit the ground, the speed is going to be 6.45 meters per second squared. But hang on, it's going down, U is going up, velocity, remember velocity has direction, so if U is a positive value going up, then when we're going down, the final velocity we need to be thinking about has to be negative. It has to be minus 6.45. We already talked and we know acceleration due to gravity. We're thinking this problem, we're thinking it from a perspective of going up. That's our direction because that's where we started. That means acceleration due to gravity is minus 9.8 meters per second squared. Let me just make it a bit clearer. I did a little graphic here. I hope you like it. It's cool. That's our starting point. We're starting at U. What happens here? Remember, think about it. Acceleration is minus 9.8. That means acceleration is going to be decreasing and decreasing and decreasing. That's why I have this line here. The velocity has to just be getting smaller and smaller and smaller. And, well, if this is U, at the point where it gets to the top, and the ball is going to start to come back down, the velocity is going to be 0. Now, also consider when we get to the next stage, what do you think about that? When it gets to this position, when it's back at P, the velocity has to be minus U. Why? Well, it's at the same, it traveled the same distance it traveled to go up is the same distance to go down. And we need to start thinking if this is the same distance up, same distance down, same displacement up, the negative displacement down. Make some sense? The negative velocity down as well. Okay? By the time it gets to this point, I have the same speed. But I'm in a different direction, so I am traveling at minus U. And then finally, by the time I get to the bottom, it's going to be minus 6.45. So that's the whole journey. This, in terms of speed, that's what happens throughout. Started at U, gets to 0, gets to minus U when it's back where it started, and then it gets, when it's about to hit the ground, minus 6.45 meters per second. Now, we asked to find U. We know A, we know V, we also know T, 0.75 seconds. I can put that up. Those are the values we have, T, V, A. So we can use V is equal to U plus AT. Clearly that came up on the screen much sooner than it should have. Naughty, naughty, naughty. I got to reprogram this PowerPoint, but I'll do that later on. We substitute the values. Rearrange, you get U 0.9, sorted.